Alright, so let's double check to see. I think I'm recording. I think when that's blinking, I'm recording. If not, I'm recording now. Alright, so we're going to begin to look at combination of transformations, and the order that we do these transformations is going to become important, especially as the number of transformations increase, like we noticed in that previous problem in number 10. So again, I'm going to refer to this. You really need to eventually commit this to memory and understand it. The first two transformations are affecting the x coordinates, the domain. You can see that it's inside the parentheses, and the last two here, it's outside of the parentheses. You can see that you're multiplying the y coordinate here, and you're adding or subtracting to the y coordinate. All right, so let's take a look then. Here we have a parent function that's x squared. So let's call f of x squared. And the first thing that we think of is shifts to the left or to the right, and that's this minus 3 that's on the inside. So we're always going to start with the transformations on the domain, on the x, and then work outward and do transformations on the y. So if I refer to this as my first step in getting my final graph of g, then this minus 3, this x minus 3, how would I describe that transformation? Well, you would take the graph that's immediately above it, the f. So maybe I should type this out. It might be faster. To obtain, I'm not that fast of a typist, maybe it's not. To obtain the graph of what we're calling G1, we shift the graph of f to the right 3 units. It's bizarre in its behavior. Let's shrink this. Make this a smaller font so you can read it a little bit better. So that's my first transformation. Now I need to transform this graph that we call G1 into a graph that I'm going to call G2 just for step 2. And I'm going to, again, refer back to these vertical compressions, the stretches or the shrinks, and recognize that 2 times this being the output, you're multiplying the output of what you squared by 2. That's a vertical stretch by a factor of 2. So when I take 2 times this previous function, G1, which we can write as 2 times x minus 3 quantity squared. Let's describe what the graph would look like. So to obtain the graph of what I'm calling G2, we vertically stretch the graph of G1, the previous graph, by a factor of 2. And that's an important thing to recognize, that you're not constantly starting over with the parent function. The parent function is used in the first transformation, then that new graph is used in the second transformation, and then this graph will be used in the third. It builds on itself. All right. So now for our final transformation. So this is actually going to be my final graph G, that I'm going to take the graph of that from my step 2 the graph of G2, and I'm going to shift it down 4 units. So this G2 was 2x minus 3 minus 4. So to obtain our final graph, and our final graph we're calling G, we shift the graph, the previous graph, which we just numbered them 1, 2. We shift the graph of G2 down 4 units. Alright, so I'm going to use that Desmos graphing calculator real quick to try to illustrate. If you don't like that, well, you can stop the video. You don't have to watch the whole thing. So my parent function is this parabola that is the squaring function that the vertex sets at the origin and it opens upward. My first transformation was to shift this graph to the right 3 units. So even though it was minus 3, I can see that it shifted to the graph 3 units. So now I'm working with this graph. To obtain my next graph, I use the graph of G1 and I vertically stretch it by 2. So you can see that by taking a point and vertically stretching it away from the x-axis, that it opens more narrow now than it did before. And now for my final graph that we call G, I'm taking the previous graph and moving it, what, did we move it down 2 units? I already forget. No, 4 units. So it's this graph that was vertically stretched 2 units is now moved down 4 units. So let's see if this graph through this transformation really is the graph of the function they gave us. They gave us 2 times the quantity x minus 3 squared minus 4. Okay, so let's make this bigger. You can see that if I toggle, well, if I the colors sometimes are difficult to see. If I toggle this orange off, there's my answer at the end of my third transformation. There it is in purple. If I graph this function they gave me, there it is right on top of it. You can see that these are the same graph. So this original parent function got shifted to the right 3 units, then it got vertically stretched, and then it shifted down 4 units, and that's what we have. So that's why I keep saying that this Desmos graphing calculator is really nice to helping you understand this. Let's make sure that we've answered our question. Identify the parent function. Well, that was the quadratic function, sometimes called the squaring function. And the graph of it's often referred to as a parabola. And describe the sequence of transformations that can be used to produce this new graph. So this sequence of transformations was these individual steps. Take the original parent function and shift it to the right 3 units. Then take that resulting graph and vertically stretch it by a factor of 2. Then take that resulting graph and shift it down 4 units, and you'll end up with the correct graph. So I hope this helps.